So do you see on this question how they're asking us the annual growth rate? So while we certainly can do this problem using that y equals AE to the KT model, because they're asking for annual, it's going to be less steps to use the AB to the X model, AB to the T model. So what I did was, let's see, let me find the work here. So I did both, and notice they told us that in 94 here, in 94, the house was worth 110,000, and then what is that? 8 years later, it was worth 150,000. So what I did is I wrote a pair of coordinates for that. I wrote 0, 110,000, and 8, 150,000, and then because I don't want to write all those zeros, there's nothing wrong with writing, 0, 110, and 8, 150. I mean, I guess I could even written 0, 11, and 8, 150, or 8, 15, but then I got to think a little harder. I mean, I know if I just got to multiply by 1,000, that's easy. So I did this both ways because I saw that you use the continuous model, which is fine, but you're going to see why it might be easier to go with the annual model in this case. So y equals AB to the X, I said, and so since it's times 0, that's my initial value, right? So 110, and that's A, and then I have substituted in the 8 for X and the 150 for Y. And then I divided by 110, took the 8th root, and I came up with that number. And I know that B, that multiplication factor is always in the form 1 plus whatever the annual growth rate is. So I knew that was 1 plus 0.03951, whatever it is, right? So I know that's R, and that's what they're looking for A. Now they're looking for 4 decimal places, and my open math sometimes it's better to give them a little bit more. So I went till I didn't have to round anymore. Round, that's what I gave them. And then change that to a percentage, multiply it by 100. So move the decimal point over twice. And then that's answers A and B. And then I wrote my equation. And then they said, what was the value in 2002, was it? In 2007, which is, if I did my arithmetic right, that's at year 13. So I just wrote 110 times that B number, that growth factor, by raised to the 13th, and I timed that answer by 1,000, and then they wanted that rounded to the nearest thousand, so 182,000 is what we'll go with. Now, what if we wanted to go about this using the AE to the KT model, AE to the X model here? Let me get a pointer going on here. So same setup, Y is 150, A is 110, and we know T is 8. So I divided by 110. I took the natural log of both sides to get the 8K out of the exponent, and then divided by 8, and I came up with this number. And I'm very glad you asked this question, because on this next exam, I'm going to ask you to take the continuous growth model, convert it into an annual, and vice versa. Okay, so if you're going to build a continuous model, the E to the KT thing, that's a continuous, so it's compounding continuously if you think about this in money terms. We have to change that to an annual model because they're looking for the annual growth rate. So I know that the two equations are supposed to be giving me the same answers, right? Regardless of the model. So A is the same and the X is the same. So that must mean that B is equal to E to the K. Well, we know K is that number. So I just raised E to that power and I got that. And then notice that's exactly the same as the annual. Okay, so, and then I could continue that with on the side, but I've already did it with the annual model, but so from there it's pretty straightforward, but that's how you get started with that A, and then times it by 100, get rid of the 1 times by 100 to get the growth. And then you could write that equation if you wanted to use that continuous model and substitute T in for 13. Okay, so hopefully that helps.